Alright, hello everybody. I just want to show you guys real quickly here the concept of inverse function graphs. Okay, and there's a certain characteristic of these graphs that we can look at. Okay, and I brought in Desmos to help me out. Okay, so we're just going to look at a couple questions and just analyze these based on what we know about inverse functions. Okay, so this first one asks us to graph x squared minus 2 and its inverse. Okay. So you guys should hopefully remember what the graph of a quadratic looks like, right? But just in case you don't, x squared minus 2, right? So that's just a normal parabola shape, just shift it down 2 spaces from that origin point, right? So if I was to sketch that graph on here, let me do that real quick. Okay, not a great drawing there, but we have our sketch of the x squared minus 2 graph on the grid there, okay? And I want to graph its inverse, okay? But to be able to graph the inverse, obviously I need to find the inverse, right? Right, and how we find this is that we switch around, we literally just swap the x and y variables, and that'll help us find it, right? So that's just, again, that's the notation of it. Sometimes you'll see that. But okay, so instead of y equals x squared minus 2, to find the inverse, we're going to do x equals y squared minus 2, and we're just going to solve it back for y, and that will give me the inverse. Okay, so in this case, I would need to plus this 2, right? I would need to plus 2 to both sides. I'm not going to show a ton of my work here. Hopefully you can follow along still. But I would have x plus 2 equals y squared. Okay, so that would be if I added this 2 to both sides, okay, and canceled that out. All right, and then from here, right, if I wanted to cancel out this y squared, I would need to take the square root of both sides. Okay, and that will cancel out with the 2 exponent there, and I would just need to take the square root here. But again, one thing with this that I mentioned briefly in the other inverse function video, okay, when we take the square root of both sides, and I'll kind of show this here and why this happens, but we need to include the positive and negative version of the radical, right? Positive and negative square root of x plus 2 equals y. So this would be the full inverse equation right here, okay? But let me just show you when I graph that what it looks like. Okay, let me just not include the plus and minus at first, and I can show you the difference. So y equals square root of x plus 2. Okay, so I want you to notice something. Okay, so the inverse of a graph, okay, I'm going to talk about what it'll look like specifically in a second, but it's supposed, just for now, the inverse of a function is supposed to be very similar in shape to the original. Okay, and when I include, right, you remember with a square root graph, it's just kind of this, like almost like a cannonball shot shooting out of a cannon, right? You just kind of shoot it up and it keeps going. So we have this shape, right? But it's only half of the parabola, basically, like turned on its side. So that's when I include the negative square root of x plus 2. You see that that kind of completes the other side of that parabola, right? So now I kind of have this full true like reflection of the other graph, right? So that's what that would look like. And let me sketch that over to the graph here, and then I'll kind of explain what the inverse itself, kind of how we would identify that. Again, not the best drawer here. It definitely looks better on on Desmos, but you guys get the idea, right? If you were drawing this yourself on the test, that's what you'd have to draw. Okay, but we have this equation. Okay, and again, so what's the deal with the plus and minus? Why do we need that? And then what's like? Why does this happen on the graphs? Okay, what happens with inverse function graphs is that these graphs. So that, let me explain what that means. So the graph of an inverse reflects over the line y equals x. So okay, let me just put that line in here. That'll help you to see. So if I put in the line y equals x, okay, I want you to notice that like with the original red parabola here, and let me I can make these disappear. So we see this graph kind of in its relation to the line y equals x, right? It kind of curves, it comes down, and goes the other side, right? So if we were to like reflect this red line across the x-axis, kind of like make it a mirror image on the other side of that, look what happens when I bring in the square root graph. It's that exact thing, right? It's like that exact mirror image of that. And so that's how we know that something is a graph of an inverse, is that it reflects over that line y equals x, right? That's just the line that goes through the origin and would go up 1 over 1 as the slope, right, just this line that goes diagonally straight through the middle of the graph. Okay, so every inverse, right? So when you graph an original and then you find its inverse and you graph that, they're always going to reflect over this line. So that's kind of like your guideline as you do problems like this to ensure that, okay, I found the proper inverse. Is you kind of check it by saying, okay, does it look the same on both sides of that line, y equals x? And in this case, it does. Okay. So just one more question that I'll go over and then I'll be done. So this one says, write an x in the blank beside each graph which shows a function paired with its inverse. Okay, and in this case we're not given the equation, so we're not able to check it that way. So the only thing we can use to kind of check this is this right here. Does the graph reflect over the line y equals x? So what you can do is kind of include a line going right y equals x. So like that'll be my line right here, kind of cutting diagonally from the bottom left to the top right corner. And I'll include that in every graph here. And so what I want to look at is, okay, like, is it a reflection? Does the graph kind of like have a mirror image from one side of the graph to the other? Okay, and we'll be able to answer that based on kind of this comparison. Okay, and so when we look at these four graphs, right, number 15, I would say yes. I would say yes, this is a good reflection, right? It doesn't quite look the same as this, but this would still be a good reflection because again, it's kind of like a mirror image on one side of the graph to the other. Okay, so I would say yes, this is a good reflection. Alright guys, so and then for this second one, as we look at this second one, I kind of sketched it over here to kind of give you an idea. Okay, again, with these square root graphs, we kind of are only given like half of the picture here. And so we would see that like the inverse, if I was to reflect this red line across the line y equals x, I would get something that looks more like this. Again, it shows the whole parabola here, but mainly it would be the right side of this. But either way you look at it, no, this would not be a good reflection. So we would not write an x in the blank because that is not an inverse of that, right? Having the line go down this way, that would be a different type of relationship, but it's not its inverse. Okay. Now this third one, these are two straight lines. Okay. So we see this, and these are actually two very simple lines that I can show on here. Okay. So I'll keep that guideline y equals x. So one of the lines is y equals 2x, and one of the lines is y equals 1/2 x. So if you're able to like identify by looking at the graph, like, hey, what are these two equations? And you could kind of check mathematically, find the inverse of one of the equations and see, okay, does that match? But in this case, yes, we do have a good inverse relationship here because, yeah, this does indeed show a line kind of reflected over across the line y equals x. I know there's kind of two different sides to this one, but yeah, it's like the exact mirror image on either side of it with both lines kind of meeting at the middle here. So yes, this is a good one. So we could put a check mark near that one as well. Okay, I guess it's an X, but you guys get the idea. And then this last one, right? So we have two different lines. These are actually two different graphs of a cubic graph, if you recognize that parent function. And no, this one would not be either. I'm not even going to type these on here because, again, we see that, again, it should be a mirror image. So, right, maybe more like what the blue one would look like if it was a true inverse would be something like this. It would come up and then maybe come down and then go up like that. Actually, more like a cube root graph is what that would look like, right? So that's what we would actually look like. So you can see, like, if you compare that to the red one and then kind of ignore the blue one that's there, like this is an actual mirrored image of that one instead of the blue one that they have on there. Okay. So no, this last one would not be an inverse either. Okay. Okay, guys, so that's the idea. That's, again, the key here is that the inverse reflects over this line y equals x. You want to compare any graphs with its inverse based on that line. Okay. So that's all for this one, guys. Thanks for following. Hope it makes sense. Good job.